Okay, so we're back with parent functions and offspring. And so you'll notice here that I have a absolute value parent function or offspring function up here. Now I went ahead and labeled the vertex as -1, 3. Remember how we get that is the h value on the inside lies. So it's the opposite of +1, which is a -1. And the k value tells you the truth, so it stays a +3. So my new vertex is -1, 3. But I also want to recognize the a value now is a negative. So when I finish with this absolute value function, I should have a v graph, but the v graph should be concave down because the a value is a negative. We're going to plug in some points over here and look at how this works on the table with that negative number in front of the absolute value. So the numbers around -1 that I want to plug in, I want to look at -2 and -3 and also 0 and 1. So I already know at -1 I get a 3. Okay, I'm going to use some scrap paper here just to have more room to show you. So if I plug in my -3, so if we look at, here's my function, I plug in -3 for that x. Then I'm going to show some work here. PEMDAS says inside first, so -3 plus 1 is a -2. And then PEMDAS again says still work inside, and I got to keep working until I get rid of these bars. So what is the absolute value of a -2? Well, it's going to be a +2. And notice how my bars now change to parentheses. Then I can take and do my multiplication, -1 times 2 to get -2. Then I can finally do my addition, -2 plus 3, and I get 1. So in this case, I get the order pair -3, +1. Okay, I'm going to show you again, but I'm going to do it with a -2 this time. So again, still using my scrap paper. There's more room here to show you the work, and I can write bigger. So here's my function. In place of the x, I want to plug in my -2. PEMDAS says parentheses. The bars are just like parentheses. So -2 plus 1 is a -1. Still working until I get rid of my bars. My bars turn into parentheses when I actually use the bars. Remember, the absolute value of a negative number turns to a positive. And now I can multiply my -1 and +1 to get -1. I can add -1 plus 3, and I get 2. So in this case, I get -2, 2. Alright. Already know what my -1 is. That was my vertex. Now I can look at plugging in 0. Well, again, taking my function, plug in 0 in place of the x. PEMDAS says inside first, so 0 plus 1. I get a 1 inside. Use the absolute value. Absolute value of +1 stays a +1. Then multiply. I get a -1 plus 3, which gives me a 2. Do the same thing with my 1. Same thing with my 1, so plugging in -1, and I put a 1 in place of that x. Inside the bars first means I get a 2. Absolute value of 2 stays 2, but now I change to parentheses because I've used my absolute value. I multiply to get a -2, then I add to get my +1. And so now I have these new x values that I can plot on this graph and hopefully have a concave down absolute value function. So I'm going to plot my -3, 1. Here's -3, 1. Plot my -2, 2. Puts me here. I've already got my -1, 3 there. Plotting 0, 2 puts me here. And plotting 1, 1 puts me here. We can see a V shape, and that V shape definitely makes a concave down graph looking like that. Okay, so looking at my next example here, it's a quadratic problem because I have a squaring. My a value is a 1, so I'm going to have a negative or concave down quadratic graph. And my new vertex. Take a second to yourself. Hopefully by now we can find this new vertex in like 10 seconds. Remember, the inside, the h lies to you. The outside, the k, tells you it stays the same. So instead of -2, I have a +2, and my -1 stays the same. Okay, so doing this, we're going to have numbers around 2. So over here, let's put in 2. I have 1 and 0 beforehand, 3 and 4 after. I'll use my scrap paper again so I have more room to show you the work. So I plug in a 0. Again, using your function. In place of that x, I'll plug in a 0. I'm going to do my parentheses first because that's what PEMDAS says. So 0 minus 2 is a negative 2. Then PEMDAS says to do exponents. So negative 2 squared. Negative 2 times negative 2 is a positive 4. And then I got to multiply by this understood negative 1 here to make it a negative 4. And then I do my subtraction to get a negative 5. So 0 gives me a negative 5. Let's do the same thing now with our 1. I'm going to plug in, again, instead of x, I put that 1. I do PEMDAS. 1 minus 2 is negative 1. PEMDAS says to square, or use exponents next. A negative times a negative gives me a positive 1. Then I got to remember to multiply by this negative a value, so I get a negative 1 minus 1, so I get a negative 2. I already know my vertex was 2, negative 1, so that one's finished. I can plug in 3 next, the same way I have been. 3 in place of my x value, working inside parentheses first to get a 1. Squaring that 1, I get a 1. Multiplying by a negative a value, I get negative 1. Subtracting 1, I get negative 2. Plug in your 4. This process is never going to change. It's always PEMDAS. Even though we think we don't use it anymore, we still use it. 4 minus 2 is 2. 2 squared is 4. Multiply by that negative a value, do your subtraction. So you get these numbers here. Okay, so I'm going to go ahead and plot my coordinates on my coordinate plane I just drew. So 0, negative 5, so here's my 0 on the x, negative 5 on the y, puts me down here. 1, negative 2 puts me here. 2, negative 1. 3, negative 2. 4, negative 5. Again, draw this to be curved, quadratic right here, concave down. Looks like that. Okay, so now we'll pick up with our red function down here. It's going to be our cubic function. We know a positive cubic function looks like this. So let's figure out what a negative cubic function is going to look like. Because I know we say concave up and concave down with these even functions, but it's kind of hard to see with a cubic function what would happen. But basically, you're just going to flip-flop your arrows. It's going to change your end behavior. All right. Our new vertex, again, this process doesn't change. Look inside, take the opposite. Outside stays the same. So we know we have negative 1, 2. Numbers around negative 1, negative 2, negative 3, and then 0, 1. So we're going to plug in here. We're going to plug and chug basically until we get some answers out. So I want to use some scrap paper again. Plugging in negative 3. Inside parentheses, negative 3 plus 1 is negative 2. Negative 2 cubed. Be careful with that. It's going to be an 8, but it's going to be a negative 8 because you have 3 negative signs. Then multiply by this a value of negative 1 actually gives you a positive 8. And 8 plus 2, we get our 10. Okay? I keep on going here. If I plug in negative 2. Inside parentheses, I get negative 1. Negative 1 cubed is actually a negative 1. Multiply this negative 1 by a negative a value, and I get a positive 1. And 1 plus 2 is 3. So I can jump on down now to plugging in my 0. I plug in that 0. 0 plus 1 is 1. 1 cubed is 1. Multiply by that negative a value gives me a negative 1. Add my 2 and I get a positive 1. My last number I'm plugging in is that 1. So let's do some simple math again here. 1 plus 1. 1 plus 1 gives me a 2. 2 cubed we said was 8. 8 times a negative 1 gives me a negative 8. And then add to get your negative 6. As we're going to plot these points here on the graph I just drew. So we're going to plot the point -3, 10 first. So here's my -3, 2, 4, 6, 8, 10 puts me up here. -2, 3 puts me here. -1, 2 is here. 0, 1 is there, and 1, -6. So here's my 1, 2, 4, 6 puts me here. And so you'll notice that the end behavior did change. Basically, it just flip-flops which arrow points up and which one points down. And this is what the negative a value does to a cubic function. We're going to do one more. We're going to see what happens to this square root function, and then we'll end this video. Okay? So the square root function, my vertex, it's going to be a +1, +2. Again, inside lies to you. A +1, +2. We got to figure out which side we can actually use. Could I actually use my 0 side or my 2 side? If I plug in a 0 here, I'm going to get 0 minus 1. That's actually going to give me the square root of a negative number, so I cannot use this 0 side. So I have to go the other way. Okay? So I'm just going to show my work here for these problems. I'll plug in my 2. 2 minus 1 gives me a 1. What is the square root of 1? Well, that's 1. I have to multiply by this negative a value, so it's going to give me a -1, plus a 2, which actually gives me a 1. So I get the order pair 2, 1. Then I want to see, can I plug in a 3? Well, if I plug in a 3, inside my radical, I get a 2. And I don't know what the square root of 2 is without a calculator. Even with that, I would get a decimal, so I don't want to use that. So I don't want to use 3. So I'm going to move to 4. If I plug in a 4, that's going to give me the square root of 3. I don't know that either, so I don't want to use 4. Let's jump to my next number. Let's plug in a 5. Okay. Well, if I plug in a 5, 5 minus 1. Hey, I like 5 minus 1 because it gives me a 4. And I know the square root of 4 is a 2. Then I can multiply that 2 by that -1. Then I can add, and I get a 0. So that's how I get at least 3 points here. I've got to find the ones with perfect squares. So if I make my graph real quick, I should have already had one drawn, but I didn't. That's okay. I can plot these points. 1, 2 puts me here. 2, 1 puts me here. And 5, 0 puts me here. And you'll notice that this is my first point. My graph is going to now look like that. So remember that the parent function graph looks like this. So basically the a value, again, just reflected it, just like it does all the other ones. It turned it from, this direction. It just flipped it completely over the x-axis basically, and it looks like this.